Hello everyone, welcome back to the channel. And in this video, I've got a little project here that we're going to be putting together, and it's the XTIDE. Today we're going to be assembling this thing, getting it all soldered up, programming it, and if all goes well, installing it into the IBM 5150 to give it a hard drive solution, which is something the PC and XT clones and compatibles desperately need because, well, let's face it, floppy swapping, it wasn't fun then, and it's not fun today. So let's get started. Before we do though, I kind of want to explain a little bit about what XTIDE is and why it's actually a really neat little project and something that a lot of these older computers, especially on the PC side, really could use. So to understand this fully, we need to go back in time a little bit to, well, the late 70s and early 80s with the rise of the home computers that were dubbed the 8-bit micros. And they were called microcomputers because they were a lot smaller than the refrigerator-sized mini computers and definitely smaller than the room-sized mainframe computers. Now, even though the minis and the mainframes did have spinning disk hard drives, a lot of the home computers at the time weren't expected to have hard drives at all just because of, well, price of these things. Hard drives back then were very, very expensive. And most software during those times were expected to come on a couple formats. Cassettes, cartridges, or depending on the micro, floppies, specifically of the 8 and 5 1/4 variety. Computers like the Commodore 64, the VIC-20, the Apple II, the Atari 8-bit line, Coco line, all of these did not come designed to use a hard drive in any capacity. Even the legendary IBM 5150, which started the PC architecture and is known for having hard drives later, originally was never designed to have a hard drive, hence why a lot of the early ROM revisions could not boot from an external ROM such as a hard drive controller or, well, any other external ROMs. However, as time went on, especially on the PC line side of things, hard drives did start coming a little bit standard, starting with the IBM PC XE, the 5160, which I've shown in some previous videos. It has that massive double height 10 megabyte hard drive, which then later shrunk down to these half height 5 1/4 inch hard drives. But the fact remains, a lot of these early computers couldn't really utilize hard drives. Now on the PC line of things, that's where the XTIDE comes in. These hard drives run on an 8-bit bus because that's what the original PC and the PC XT had for its expansion slot. This was before they were called ISA or ISA. But yes, these use an 8-bit data bus, which means data went from the CPU to the controller card to this in an 8-bit fashion. The same 8-bit wide as floppy drives used, which is why floppy controllers and hard drive controllers back then were 8-bit controllers. As time went on with hard drives, the data bus increased, especially with the advent of the 5170, the PC AT, because it had a 16-bit CPU and a 16-bit data bus, which is why controller cards changed a little bit during this time. Now, it is true that yes, the early 5170s did still use the 8-bit bus, but some of the later ones did come equipped with these controller cards, which were 16-bit. These were designed to still use the 8-bit style MFM or later RLL style controller, but just on a 16-bit bus for some extra data. Now again, at the time, hard drives still were 8-bit, so that wasn't that big of a deal. However, that led on to the evolution of 16-bit hard drives, much like this mini scribe hard drive here. This is kind of a weird middle ground area because it does use a 16-bit bus, but the drive itself is 8-bit. That's what this little card here is. It's an adapter board, but you get the idea. You needed an adapter to go from the 8-bit bus of the older PCs to the 16-bit bus, which was later called IDE of later PCs. And the problem is, modern days, you can't just stick a 16-bit IDE drive inside of a PC XT or XT clone, even if you had a controller that would plug into an 8-bit bus, it still would not fully function because the data bit problem. Hence why these weird hybrid drives existed, because it was a 16-bit controller with an 8-bit adapter. And years and years ago, there was no hard drive solutions for this. Once these MFM drives failed, once the RLL drives failed, things were done. You couldn't install a hard drive anymore unless you tracked down another working drive. But several years ago, way smarter people on some internet forums figured out a way to not only reverse engineer some of these adapter boards, but also was able to utilize them to create new 8-bit controllers that would utilize CF cards as a hard disk solution by basically slowing down the data rate from the 16-bit wide CF card down to 8 bits so that the PC and PC clones can utilize them. And that's where these XTIDE cards come in. Now ignore this one. This one's my faulty one, which is why we're doing this video, because I'm building a new one. But effectively, how XTIDE works is it intercepts and interrupts the CPU bus to the IDE card, which is the IDE controller, which is the CF card, interrupts it, and like I said before, it basically slows it down to an 8-bit so that 16-bit drives can be used. It doesn't have to be CF cards. It can actually be IDE drives if you have the right hardware for it. This one uses CF cards. Some of the really simple ones are literally just the ROM chip, some supporting chips, and then it kind of expects you to have a secondary controller card in the bus to be able to control the IDE drive. But for the most part, CF cards seem to be the de facto standard because they basically add a solid-state hard disk solution to your PC and XT clones. Now, I do want to say before we get started, there's a caveat with this. Not every PC, XT, and their clones and compatibles can use an XTIDE. For example, like I said before, the very earliest of the 5150s cannot use these because it's an external booting ROM. They can't even use EGA or VGA cards because of the way the BIOS is set up. They didn't expect anything to have an external booting ROM, so they didn't implement it in the BIOS, which is why the latest of the 5150 BIOSes are a lot better because they can handle external booting ROMs. The same thing with the very, very early compact portables. They have the same BIOS problem with utilizing XTIDE. However, those are a lot easier to update the BIOS to a later revision to allow using these. And also, if you have a XT class clone or compatible that uses a non-standard memory address for how it would handle boot ROMs like this, it won't work without some modifications and alterations to the XTIDE BIOS itself and setting dip switches. But yeah, so the scope of this video is us getting this one put together, programmed, and all that stuff to work with the PC 5150, which is what this one's probably going to be used for, even though I probably will be popping it in and out to use in any other XT class machines I have in the future. So let's just get started building this thing and see how it goes. And here is the XTIDE in its little baggie, so let's get it dumped out on the bench. Here's all the little goodies, including the bracket, the resistors, the caps, the sockets. And the star of the show, the AT2864B and all the supporting chips. Here's the main PCB in a gorgeous black and gold coloring. Looks super clean, and the silk screening is very legible. We're going to start with the caps, bending out the legs to make them properly fit, like so. And then bending them on the backside to keep them in place. Time to solder, and I'll admit I'm not the best at this, and finding a good angle to record it was a bit of a pain, so I just did it from here. And there we go. All the caps done, and I don't think I did too bad of a job here. Time to snip them off, which meant some of them went flying, so I started to hold them one at a time. All done. Now for the resistors, and these can be a pain. notice the stripes here, they indicate different values, and if you don't know them right off, it can be a bit of a challenge. Luckily on this project like this, there's only a few, and only two different values, 10 k ohm and 4.7 k ohm. Both clearly marked on the PCB here and here. And also, luckily, the resistors say their values on the little tape at the end. Makes it easy in this regard anyway. Same as the caps, bend the legs, insert, and bend them to hold them in place to solder, like so. Looking pretty good. Make sure you take the time and line up the value stripes so it makes it look more polished. Now time for the sockets, and this, yeah, didn't go well. I tried to cheat and place them on the PCB to try and save time, flip it over and solder, but they all fell off, so I opted to solder sockets one at a time. Soldering the corners first to hold it down. After some time, I got the sockets put on, looking pretty good, and I also did the resistor packs, making sure to line them up on the dot on pin 1. Time for the switch blocks, and same as the sockets, corners first, then fill in the pins with solder one by one. There we go. Time for the jumper pins, cutting them to size, and they fit pretty snugly, so I didn't have to hold them at all. They just needed to be soldered in. And time for the big cap and the LED, which on the cap you lined up polarity, and I bent the pins like the other caps. The LED was tricky. I had to actually look up the polarity markings to know which one was which. And time for the final part, the IDE connector and all 44 pins. Time to scrub off the flux with alcohol to avoid shorts. And all done, looking good. Time to install the jumpers and chips, bending the legs just enough to line them up and pop into place. Now with all that done, I'm going to go look up online to set the switches and the jumpers. After I attached the bracket I nearly forgot about. Okay, so here it is all put together. All the jumpers are in place. All the switches are set to the one I showed on -0degrees.net. Brackets on, no solder bridges. So let's get installed in my 5150 here and figure it with a floppy. Okay, we got it plugged in. Let's just see if explosions happen. Hope not. Okay, no explosions. Okay. So we got DOS loaded. Okay, so I went upstairs and I wrote it's a non-bootable image, unfortunately. It just got some data on it, but this should have the XTIDE config and the right bin file for that. Okay, so we should be load BIOS from file. Should be this one. Okay, press enter. Okay, so we should be able to configure. Oh, here we go. Alright, cool. And what's interesting is that this is showing this, considering that this is not a Hercules card, this is the MDA card. So that's actually pretty interesting. Okay, so let's close. Okay, let's power it down and power it back up. Pop in DOS because there shouldn't be anything on that. I don't have a CF card on that yet, so let's just see what happens. And look at that. It booted with the XTIDE BIOS. That is awesome. Probably not going to detect. Yep, not found. Booting straight into the floppy drive. Okay, now let's get a hard drive installed into this. Okay, so what we're going to try for this one is this little CF2 IDE adapter. This is one that I've used several times before, and it's actually one of the options to use for this. The other option is to use an actual IDE cable and hook up to an IDE drive. I'm not going to do that. And this CF card is from my old XTIDE that quit working. I'm going to see if I can diagnose this one. But we're going to see if, well, it'll even boot to this one. All the information should still be on here, so we'll just see. Well, the card lit up, but not the XTIDE card. So I might have that LED wired in backwards, actually. That might be something I fix later. I'll pop this DOS floppy so that it doesn't try to boot it. And yeah, this is that IBM DOS floppy that I picked up a while ago. Now, if this doesn't work, I'll go through the procedure of how to reinstall DOS onto the CF card. That's taking a while. Okay, so it didn't find it. That's a problem. Okay, just for fun, this is the 1 GB card that I usually use for my when I'm doing some stuff on my 486 to make floppies. So we'll see if this will boot with this one. If it does, it means I have some dead CF cards I need to replace. Yeah, it's still not wanting to boot. Okay. So I might have other issues going on. something's weird. I'll have to do some diagnosing, I guess. Okay, progress. So kind of a recap of what I did. I turned the camera off because I was, swapping cards out and I was trying some other things and other things. So this Transcend one that I use for my DOS stuff. I use this to make floppies and stuff with my 486 and try stuff out, just because it's easier to do this and try and use floppies all the time. This would detect, but it wouldn't fully load up DOS. And that's because this version of DOS is 6.22 and it has a lot of stuff added in, CD-ROM drivers and high mem drivers, and it locked up and hung, which is kind of expected, but it did detect. So I did at least build the card right, and the card that was in here wouldn't detect, and neither would the original one out of the 5170, because it quit reading at some point, so I thought, I'll try it, but no, it wouldn't detect. So kind of on a hunch, I took the original card that was in my original XTIDE, the one that quit working, and I took it upstairs, copied all the files off it, because it did read on a Windows 11 desktop, and I completely wiped it. I went into disk apart and just cleaned it, wiped it, completely, sanitized it, whatever you want to call it. So after cleaning it up, whatever, I popped it in here, and it actually detected, the XTIDE actually detected it. So I went in, and there's a certain way of how to do this. First, if you're using a CF card, you have to fdisk/mbr. That's important because it resets the master boot record, which that one did not have because I wiped it. So now it did. And then you want to format C/sys, which installs sys files onto it, so it makes it bootable. And look at that. Format complete, system transferred. We have 30,490 whatever bytes total, 57K basically used by system, 30 million more bytes available. So I have a full 32, it's a 64 meg card, but it's 32 meg, that's the highest that 2.1 can see. So this should mean I should be able to, yes, I have a booting CF card with DOS. Yeah, let's just power down and see it boot. And look at that. Toshiba, whatever, booting CC. Maybe. Non-system. Oh, crap. Okay, so I still have to do some thing here. Maybe I need to redo the MBR. Okay, so that should have worked. Okay, so maybe I didn't get this figured out. Okay, it's working enough because it is at least booting from the, or at least detected the XTIDE, and it is detecting CF card. So it is detecting, it is partially working. Detected, booting CC. Okay, that's not working. Okay, so it is now detecting the SanDisk. Okay, so this one, I went upstairs and I wiped it as well, cleaned it with Diskpart. The other one, I did the same thing too, and it won't boot when I get through this process. This is how it's supposed to be done. So, okay, IBM 2.1. fdisk/mbr, which should repair the master boot record. Create DOS partition. Okay. Boot A again. Okay, the light's flashing now, so this thing, it should now be working. Back back into F-disk. I'm going to do MBR just again, just for verification. Change active partition. Already active. Okay. Return to DOS. Format. C/sys. Pressing key. Formatting is blinking. Shouldn't take this long to format a CF card though. Well. Oh, there it goes. Okay, we have 30,600,000 total space, 57K. Okay. So now we should be able to toggle over to C, directory, command.com. Okay, so it should now be bootable. So I should be able to Control-Delete, move the floppy, C. It did detect batter missing command interpreter. Okay. Well, that's different than in the previous issue. Okay, so now it should be bootable. Batter missing command interpreter. Why is it doing that? I'm trying to remember how I did this with my original XTIDE, but I'm not remembering the certain steps. Oh, wait, no, because I didn't have to, because this already came pre-configured with a DOS 6.2 card, so something's not happy here. We'll just restart this whole thing with PC-DOS 3.1. Like, it's annoying that the card and all that stuff's working, it's just not wanting to boot, so it's a software issue at this point. STC FBI 64, booting A. The red light's on and the activity light's going on the CF adapter itself, so it is working. It's just not wanting to boot, which is a bit annoying. Format complete. Error not ready. What? Oh my god. Okay, so we have. We'll just delete the active partition. Okay, there's a certain procedure and order that needs to be done to get this to work, and the fact that this thing went bad, the fact that I had to buy a different one, or a new one to replace it, which is fine because this one it had some issues anyway. It's fine, except it's not working the way this one was. Which again, it is working, so it's not a hardware issue now, it's a software. Not ready, reading error drive C. What's going on? Okay. So it did actually boot into the Transcend. Okay. Okay, MS-DOS 6. Okay, so yeah, as you can see, I got a bunch of /16 bench. So yeah, it is working, but something's not liking something with the CF cards. I don't want to have to. Well, actually, while I'm here, let's see, sort of format. I'm going to format A. Okay, and I'm going to try and make a bootable 6.22 360K floppy with F-disk and format on it, and then we're going to try and see if we can do that one. Do it that way. Is it going to work? No idea, but I'm kind of out of options at this point. I mean, unless I have just a whole bunch of bad CF cards that are just on the verge of failing. I mean, this one's from either 2003 or 2005, and it's the one I was using for the 5170, which no longer works. So now I should be writing the sys files. But okay, either way, the XTIDE is working because I got it to boot into DOS, just not the way I was wanting it to. I was kind of hoping to have its own separate card, because I do use that card for my 46. System transferred. Okay, so we do have 20K in bad sectors, 201, so I only have 140K left I can put on that floppy. That's fine. So now, fire this back down. Okay, so this now should be booting to a version of DOS 6.22. Hopefully, if I got it created right. I had to do this before one other time too. I think I just made it as just a DOS boot disk for the Turbo XT here when I was trying to get Something working on it. Starting MS-DOS. Good. Okay. Zip. I have a DOS 6.22 360 boot disk. Awesome. Okay, so I'm going to do fdisk /br. Okay, that didn't immediately go to the fdisk thing, so maybe format now will work? Formatting 32. Okay, so now it's formatting. Okay, so maybe there's just a problem with system transferred. None. Okay, so 202 bytes used by system. That's going to use a lot of RAM though. But yeah, that's just couldnt.com 54K. So I should be able to. Sorry, MS-DOS. Okay. Yep. There's only one file, command.com. Okay. So, not the way I wanted it to go, but yeah, I'm going to go move some games and stuff over to the CF card and then yeah, try them out real quick. Okay, so I just went upstairs and copied some files and stuff over to this CF card. Some games and stuff which might be a bit of a problem. But we'll fix that here in a second because I just want to see if this XT card will fully work and boot the way I want to. There should be a nice little boot screen right here if everything goes well, just like the 5170 did before it no longer wanted to read the CF card, which is kind of a bummer because this was the PC-DOS 3.3 hard drive for it, which I'll just buy another one of these. I'll just buy another 32 megabyte CF card, but since I've got it kind of working with this one, we're going to use this card for this machine now, since it's booting and working. I tried this one too many times. I don't know what's going on with it. It just refuses to work, refuses to do anything with PC-DOS 2.1. I even tried PC-DOS 3.3 and 3.1. I even tried generic MS-DOS 3.3, and it hangs at booting C. I don't know. I don't know what's fully going on with it. I might try and go plug this into my big computer here sometime in the next, I don't know, few weeks if I get some time, and try to install DOS using it as a virtual hard drive like I did with the, actually, I don't remember where I did that to. I know I did it to something, but anyway, yeah, this one's giving me some fits, so I'm not even going to use it. But like I said, it's an old card. It's the one I actually got with this particular CF to XTIDE adapter. I have a fully working, full-featured card, so let's put the card back in, see the boots, and then we can continue on with this upgrade video. Alright, that's the XTIDE BIOS, scan disk SDC FBI 64, CC, MS-DOS. Yeah, that looks freaking awesome. MS-DOS 6.22, 5150 PC, 512K RAM with an MDA card, 32 megabyte XTIDE adapter, dual 360K floppies, any key could continue. This is what I kind of wanted an XTIDE for, because this machine really, I don't have a hard drive for it anymore since the original one, spins up but it doesn't want to boot. But yeah, this is kind of neat that I can just pull that CF card in and out and swap whatever files I want. This is awesome. So yeah, I have a command.com, the ANSI file that you just saw, that was that cool IBM text logo, DOS, check it, games, and networking, which is nothing in there yet. That's, again, for a future video. But anyway, I can't run any games on here, technically, because I'm still using the original MDA card. So, unfortunately, no games except for text games, but we can run a couple things on here real quick. We can run Check It, 8088 class PC XT machine with no math coprocessor yet, 512K RAM with 310K available. So yeah, DOS 6.22 uses up a little bit of conventional RAM. It sucks, but like I said, that's why I was kind of hoping for 2.1 or 3.3, but I'll take what I can get. No expanded, no extended. Video adapter is mono. 8025 mono, video RAM base hex B000H, 62 megabyte hard drive, but I think it's limited to, well, actually, it might actually be the full 62 meg. I might have to try that out here in a second. But 360K, BNA drive, no clock or calendar yet, parallel port, LPT1, one COM port, and one joystick port. No, there's not. I don't know why it keeps saying that. Let's run system performance. I bet it's going to be equivalent to a PC XT. All right, so we're at a 4.77 megahertz CPU. And I am going to run this again when we do the video card upgrade here in a second, because I kind of want to see if there's a performance difference. There's a weird pause right there. I don't know what that was for. Okay, video speed, 1413 CPS. No idea if that's good or bad. I'm just going to assume that's average for a machine of this class. Okay, so it looks like we have 356 dry stones, which is basically, yeah, I'm right at a PC XT, of course, shocker. And we have math stones of 7K, so yeah, pretty nice graphs there. All right, on to the next. Now that all this stuff's working, let's upgrade this thing a little bit further and play some games. Okay, in order to make this thing into a truly, well, okay, retro gaming is kind of a loose term. Anyway, into something more capable of playing games, is we're going to be installing this little guy. This is a Hercules video adapter, and it's basically the perfect drop-in upgrade for the IBM 5150 with its original MDA card, because this card can only do text only. It can't redefine any character sets. It can't do anything except for what is already in the card. It just, no redefining character sets or nothing. But this here Hercules card has the ability of doing that, and also being able to display CGA-like graphics while using the same monochrome monitor. So basically, multi-shade monochrome graphics. And what's really funny is that this is actually made by the same company that had that made the RAM card that was in here when I first tore it apart. And funnily enough, the date codes on some of these chips indicate this thing's from like 88, 89. So it's a very, very late upgrade to what would have been in here had somebody installed a Hercules card in this machine at some point. And I would say I would love to find an original Hercules card. Dave Murray, the Epic Guy, did an amazing in-depth video of what the Hercules cards can do. And I would love to find an original one because they're really neat, but I'll take what I can get with these clones. This thing is such a drop-in replacement that all we got to do is remove this behemoth. Yeah, you think the RTX cards are big? Yeah, nah. The original, the OG. All right, and that's all for upgrading. All I got to do is just power it on. And yeah, as you can see, there's no text difference here. And that would have been the big deal with an actual CGA card. The graphics would have been really chunky. The pixels would have been bigger. But yeah, there's almost no difference. Unless, let's see if check it says there's a difference. Yeah, still says mono, so no change there. Okay, so yeah, no difference in video speed. It's still 1433 or 1413. So yeah, realistically, no difference. And 356 dry stones and 7K wet stones. I think that's pretty well identical. So no performance increases so far. But this is where the improvement is. And I moved over a few games. Some games that I actually don't even know if these will fully run on this machine, but we'll just see anyway. We got Attack of the Pesky Robots, which I actually don't remember if it'll work on here. Actually, yeah, we have Hercules 640 by 300, and just so there's no there's no sound because I think my kid's trying to nap. Music device, none. And look at that. This is something the original MDA card could not do. It could not do graphics like this. Yeah, it's not coming very well on the camera, but yeah, that is actually really cool. Have a nice DOS. Let's see if Zork will work. I mean, there's no graphics for Zork, but it should just be, or it'll lock up the computer. Okay, so Zork doesn't want to load on here for some reason. Let's try let's try Battlezone, see if that works. Okay, so Battlezone doesn't work either. I played the music, but it didn't want to play anything else. Okay, how about 3 Demon? Okay, so 3 Demon doesn't want to work either. I mean, okay, like I said, I didn't know if that was actually going to or not, but well, yeah, I tried. So yeah, and there we go. The XTIDE card works perfectly now. Anyway, programming it with the XTIDE config file from floppy was actually really straightforward. And how I did that, I don't have any footage of it, unfortunately. It was I used a grease weasel to do it. I basically created a 360K floppy image in WinImage, and then copied the bin and the config file over to the image. It wasn't going to be bootable anyway, but that's besides the point. I basically used that to control it, and then from there I was able to write the information to the EEPROM, because you can actually use the XTIDE as a EEPROM for XTIDE stuff. So now if I was to buy a second project card that, say, doesn't have the programmable chip, or I buy all the components to build my own, which is probably something we do in the future, I don't have to do anything else. I can just buy blank chips and write XTIDE configs to them for future projects. No, the big headache with this was getting frickin' DOS to work and a CF card to work. This just did not want to go well for that at all. The CF card that came with my original one, I was able to wipe it using my laptop and stuff, but it just wouldn't program or it just wouldn't boot to DOS at all. Nothing I did would fix it. With any version of DOS I tried, and yes, I didn't try 6.22 on that one, which is something I probably am going to do, because I would like to try and get that CF card that I'm using in it currently back to being the DOS 3.31 for the 5170, because I do have a project I want to get done before the end of the year that does have all the 5170, so that's that's future stuff on that one. But yeah, it seemed to work just fine and perfectly. Once I got DOS installed, it works perfectly. Now I can take that up to my laptop, take it to my desktop upstairs, and just copy whatever I need over to it. Games, software, applications, the neat little boot splash screen thing that I messed around with for a little bit, which I did not make that. I will say that real quick. That was a file I downloaded off of the internet, off of a forum, but it can also be found on Adrian Black's GitHub. It's basically just a IBM splash screen that he created for his IBMs and stuff, which gives it a cool background effect for videos, basically. Yeah, XTIDEs are an amazing project. If you have any of the PC clones and compatibles, or the XT clones and compatibles that can do a boot ROM like this, and you're tired of swapping floppies constantly, I mean, don't get me wrong, using floppies is so much fun, because it brings you back to the time of when computers were in their early days, but especially home computers anyway, not the big mainframes and the guys that mess with the mini computers. But yeah, they're fun and all, but sometimes you just want something a little bit easier, especially when sometimes making floppies can involve having a bunch of in-between machines to get things rolling. XTIDE is just an amazing project, and if you, like I said, if you have any of the XT clones or compatibles, and you want to have a CF card solution for it, by all means, pick one up. They're not too expensive. Soldering them is not that really that difficult or challenging. It's actually a neat little practice project you can do to get some practice with soldering. So yeah, why not? Obviously, like I said in the intro, there's some caveats with the XTIDE. It doesn't work with certain clones and compatibles with non-standard memory addresses. The best example I can think of is Tandy. It will not work on my RLX HD. Well, the old one didn't actually. I haven't tried this new one in there. I probably should at some point. It won't work in my HX unless I have an adapter, and I think I actually have to set some jumpers for a certain RAM memory address. And it just will not work in my TL2 either, which it has its own problems. But yeah, if you have a standard PC clone, XT clone compatible, XTIDE is an amazing project and it'll work wonders. So that being said, thank you all so much for watching this probably a little bit longer video of me building this thing, getting it working. I actually didn't think it was going to give me this many fits with DOS, but no, it did. I'm going to be picking up a lot more CF cards here in the future so I can have some different operating system stuff for the 5150, the 5170, because I can CF card back for that. And also I'm going to probably need a few more of these cards in the future for the 5160 once I start its restoration, the compact portable that I have. But yeah, now I have my 5150 with a CF card hard drive solution, so now I can swap games in and out as I see fit, even though a lot of the games I tried on here didn't want to work. I'm really surprised by Zork. A little change with that. I'm really surprised that Zork didn't want to work, because Zork is text-based. There's no graphics. So I have no idea why Zork didn't want to load. It is technically, yes, I did download it offline in a games pack, so it's probably something that got tweaked with the code or something somewhere, and it's expecting to be utilized in a certain way, like on an emulator or something. I don't know. But even with the Hercules card installed, it didn't want to play many games. Of course, the games I picked probably require CGA. But yeah, anyway, that being said, thank you all so much for watching this XTIDE video. You're going to be seeing that machine a lot more here in the future now that it's working, and some other PCs and clones here in the upcoming videos, which involve a keyboard test, and hopefully probably getting the floppy drive working for that. So yeah, if you have any ideas as to some games that I can run that have specific Hercules modes, that's kind of what I want to leave this 5154 is, the text-based stuff and the ones that are going to work with Hercules, because that's going to be the Hercules machine, with the 5170 being EGA/VGA, which in the future, because I'm going to say this real quick, the 5160 works hopefully, and when I start the restoration, will be the CGA machine, which means I'll have to bump the 5170 to VGA and EGA compatible, because I only have one monitor to split between them. So yeah, if you know of any games that work solely off Hercules and 512K of RAM and can be ran off of a hard drive, not just floppy booter stuff, put it in the comments, and I'll love to try them out on that machine here in the future. And with that being said, again, thank you all so much for watching this video. I'll see you on the next one. Thanks for watching.